Okay, there we go. All right, let's see if we're ready. Are you ready? No. Almost. I got people over here playing with their phone instead of trying to be ready, right? All right, let's see if we're ready. So, class.
Yes.
Thank you, thank you. Juju.
I said it.
You said it. Okay. That's what she said. She said it. Anyway, all right. Rates of change and the derivative. Find equation of tangent line and normal line. Graph the function. Find the rate of change. Find the average velocity and instantaneous velocity. Find the derivative of a function at a number. So, what did I say that a derivative actually is? Finding a slope, right? Everything has to do with just the slope. So this is the notation for the slope formula, because we're basically doing the limit as x approaches c, as it's getting there, is actually the same thing as saying f prime of c. I'm taking the first derivative of f at c. Make sense or no? Kinda? Possibly. Now, in terms of a circle, if I have a curve and I touch that curve at a singular point, that is called a tangent. It touches it only at one point. So, slope of the tangent, which would mean I'm touching that circle only at a singular point, and so I'm getting the same thing, because we're going to be dealing with not just straight lines, but a whole bunch of curves. So at a certain point, I want to find the slope of a curve, because it changes over time. All right, and right here, normal line, tangent line, and normal line. So first, tangent line. I'm going to use my equation of a line. So there is going to be y minus y1 equals m quantity x minus x1. Guess what that is called? Do you recognize that at all? Point slope. Because I give you a point and I give you the slope, so you have point slope. So whenever you are trying to find the equation of a line, and this has to do with the tangent of the line, I need to know what the slope is first at a point, and I can get equation of the tangent line. And the normal definition of normal is that it is perpendicular to the tangent. Normal is perpendicular to the tangent. So if it's perpendicular, that means my slope is going to be opposite and reciprocal. So change signs and flip it over. That's why it turns into this. Opposite and then reciprocal of my slope. Remember that f prime is the slope. Does that make sense, or is that nonsense? Kinda? So I'm just trying to front load a lot of the stuff that you're going to be using. This last part right here is going to be important. Okay, provided this f prime exists and is not equal to 0. Because if my slope is 0, the tangent is the horizontal, the normal is vertical. So what that means is this would be the slope and the slope is going to be 0. So perpendicular to that would be straight up and down, right? So if it's that, it would be now, what is that one going to be? Undefined. That's super important, especially when we're talking about vertical lines. Because we are going to have some of those that it is going to be undefined, so you have to be able to write it as it's going to be x equals something. The equation of this one up here would be y equals something, but we get all of that. I shouldn't use c. Let's call whatever t is. Okay? So whatever our output is for that one right there. So whatever we get for c, x equals c, so that's the whole equation. This one is a y equals for that one. Yes, no, maybe? Possibly. On occasion. Okay, good. Investigate an infinite limit. Find the slope of the tangent line to the graph. F of x is x squared at c equals -2. Use the result of that. So let's go through and find this right here. X equals. Do I have another page here? Nope, I have this one. So x squared and so I'm taking the limit as x approaches 2, and I'm going to have my equation back here, right here. I'm going to use this. X approaches 2, my c is 2, f of x minus f of c over x minus c. Is it negative? Did I screw it up? -2, thank you. Man, see? I got new glasses, now I can't see. There we go, -2. I'm not joking, I can't, because it's like, it's weird, they don't fit right. So like right here, my peripheral, I don't know. So anyway, so if it's -2, so it's going to be f of x, which is going to be for this one. So my f of x is going to be right here, which is x squared minus f of c. That means I'm going to plug in -2. -2 squared is going to be a +4 over x minus c Yes? Okay. Now, 2 negatives make a positive. 2 negatives make a positive. So let's change that up. And what can I do with that top right there? Do what? Factor, right? Is it different squares? Okay. So I get x plus 2, x minus 2 over x plus 2. And then I'm trying to find a limit as this. So now I can do the limit as x approaches -2, which is going to give me -4. So going back again, so we're going to say that f prime of -2 is -4. So this is all that notation from the, I don't know, first or second slide. Okay, find slope of the tangent line, right there. Use the result from A to find an equation for the tangent line when this here. So C is 2. Now I gotta figure out what that actually represents. So if C is 2, my y value, to figure out the y value, all I have to do is plug that in, right? Okay, plug in -2, and I get 4. So this is my point. So now I have a point, and I have a slope, which is -4. So going back to that formula I gave you guys, the point slope, I'm going to plug that into my point slope. Change of colors. Y minus y1, quantity x minus x1, like that. I get y, move that one over, equals -4x minus 8. It's -4x minus 8. So I did my distribution over there, and then plus 4. The plus 4 come from right here, because I'm moving it over, because I want everything on one side, so I could have my equation as a y equals equation. Y equals -4x minus 4. And this right here is the equation of which line? Tangent. This is my tangent line. Look for your highlighters. Oh, you got it? Okay. I have others up there if you need it. Alright, there we go. So we get the tangent line. So I got that. Find the equation of the normal line. And it gave me my point again. So, what do we know about the normal line? It's perpendicular to the tangent, right? So if my slope is -4, the normal line, I'm going to use the perpendicular symbol, the normal line would be opposite reciprocal. So if this is -4, it would be 1 over +4. Does that make sense, or is that nonsense? And we're going to use the same point. My point was -2, 4, y minus 4 equals 1 over, 1 over 4 quantity x minus -2. Y equals 1 over 4 x plus 1 over 2 plus a this, I brought up something weird, and I'm hoping you guys be like, what the hell's that? Or, you're like, that's actually pretty good. Go ahead, say it. Where'd you get 8/2, right? Okay. Now, did I move over a positive 4 here? What is that? It's still 4, right? But why did I write it as 8/2? Because I'm going to have to add it to this 1/2, right? So save yourself some effort. If you already know you have to add it as a fraction, just turn it into the fraction right there, right? So I'm going to have fractions there anyway. Fractions are your friends, not food. Okay, anyway, so that makes sense? So when we actually do a whole bunch of crazy fractions later on, it's better to just keep them as fractions. Okay, don't try to decimal them because your calculator does it for you. You know, fractions are a lot easier. So combine those. Y equals 1/4 x plus 9/2. And this is which line? The normal line. It's kind of weird, right? It's referred to as the normal, but it's not. It's perpendicular, but it's the normal.
So you plug all this on the graph.
Huh? In physics? Oh, okay.
So you plug all this on the graph.
No. You can graph these. Is that what you're asking?
Can you graph it?
Can you graph this?
No, can you graph it? Like, can you graph for me? So I can see it.
I could.
Like all the equations you just did.
No. You can.
Okay. Can you go back a slide?
When I'm done here, okay?
Okay.
Alright, so where am I at? I believe I am on, I did the normal, graph this, the tangent line to f at this, and the normal line at this.
Yeah, can you graph it?
Yeah, it was the next thing. That's why I said go on. Alright, so I will pull up my calculator, which is right here. Alright, let's go ahead. My first one, my function was x squared, right? X squared, enter. My next one was, so I hit tab, and it's going to bring up F2, so that's going to be my next one, which was the tangent line, which was -4x, was that -4 or +4? -4. So there's the tangent, and what do we say the tangent does? It just touches it at a point. Just touches a point right there. And then I'm going to do the next one, hit tab for my third one, and I do my normal line, control divide, +1/4 x plus 9/2. Is it 1/4?
Yeah.
Okay. So what does that mean? Zoom, there we go. So my blue line is my function, it goes up there. So it's all connecting right here at the point where x equals 2, y equals 4. or I'm sorry, x equals negative 2, y equals 4. And then I have my normal line, which is perpendicular to my tangent line there. Does that make sense? Questions, concerns, complaints, conspiracy theories? It's a good start, hopefully. Okay. And if it asks you to graph it, okay, actually do try to etch a graph. I do have line graph paper up there if you want to use that. I have a big pack of it. So if homework actually does ask you to graph, do that. There we go. Now, finding the rate of change of a function, average rate of change. Okay, this is actually going to be the secant line. It's just a slope in between 2 points. Average rate of change is just a secant line. So I'm estimating in between 2 points. So for this one, average rate of change is the secant line. So definition instantaneous rate of change is f at c is the limit as x approaches c of the average rate of change. Symbolically, instantaneous rate of change of f at c looks like this, provided the limit exists. Now, average is just, I take my first one, last one, what do I do with those two? I add them together and divide by 2, right? That's the average. So it has nothing to do what's in between. Okay, so that's the average rate. And then instantaneous is, it's going to be at a singular point when x is equal to c. So, make sense or no? X is not equal to c for average. X is equal to c for instantaneous. Make sense? Okay. Find the rate of change of the function here at c equals 2 and any real number c. All right. At this point here, I'm going to write the limit as x approaches c, and I'm going to have f of x minus f of c over x minus c. So this is going to be f of x, which is going to be, that's this first part, minus c is going to be 2. I plug it in there. 2 squared is 4. Minus 10 is going to give me a negative 6 all over x minus 2. So now this is going to turn into x squared minus 5x plus 6 over x minus 2. So from there, I cannot plug in 2 directly, so what can I do up here? Can I factor that? Negative 2, negative 3. So this is going to factor to be x minus 2, x minus 3 over x minus 2. And so I'm left with just x minus 3. Then I can plug that in, which is going to give me negative 1. Did I mess up?
I just couldn't read that.
Okay. Yeah, my penmanship's still not very good, and the smartboard doesn't always want to work with me. Any real number C. Now, so I'm gonna cheat on this one because this is everyone's favorite part. X squared minus 5x. I had some students refer to this as voodoo magic before. This is the voodoo magic. Because it's the weirdest crap ever and it works every time. What's my exponent here? It's 2, right? The exponent is 2. You take that exponent and multiply by the number which is out front. What number is in front of that x? So I'm going to get 2 out front. Now I have an exponent that I already used. So when I do this, I need to just subtract 1 from my exponent. 2 minus 1? It's 1, right? So that's just going to be an x to the first. I'm going to do the same thing to the next part. Bring this over, so it's minus. What's my exponent over here? It's 1, right? It's 1. It's implied that it's there. Yeah. Okay. Yeah. So it's going to be 1 times 5, which is 5. But what did I say to do with that exponent? Minus 1, right? I'm going to subtract 1. What is 1 minus 1? Anything to the 0 power is? Anything to the 0 power is 1. Okay, that's important. So it's going to be 1 times negative 5. That's crazy, right? It's like a whole bunch of made-up crap at the same time. Like, where the French toast did that come from? Anyway, but guess what? The slope at any given point is represented by this. Now, we went through and did all that work to find using the limit, right? We did a bunch of work using the limit to actually try and find the slope at that point. If this says that f prime of x, so any given point, so if I say f prime of, what was it, negative 2 or positive 2? Positive 2. So we could say f prime of 2 is going to be, is that what we came up with when we did the limit process? Yeah, that's the same thing. So we could use this voodoo magic to try to actually get the equation all the time for any given point. Now we're just going to start working on other type of crazy problems that have different rules. Same stuff, but more rules to go along with it. All right, questions, concerns, complaints, conspiracy theories. So I'm going to leave off here today, and I'll let you guys work on the homework. Make sure everyone likes, shares, and subscribes.